Hello students, good morning. Today we will start our next topic. There is a work done chapter is going on, work, power and energy. Now this topic we have done that about the energy. There is energy is a two type, kinetic and potential. These we have done. After this one we will do there is a type of force. That type of force there is a two type, conservative and non-conservative force. Conservative force, if there is a work done against the force is displacing, it depend upon the initial and final position, that will be conservative. That we can write it like this: a force is said to be conservative, is said to be conservative if work done by or against the force in displacing the object depends on initial and final points or position, that is conservative force, independent on the nature of the path. That is, for example, we can write here gravitational force, that is the gravitation force. Second is the non-conservative force. A force if is said to be non-conservative if work done by or against the force in displacing the object depends on both on initial and final, initial or final points, that is non-conservative force. For example, frictional force. For example, frictional force. Then this one is the conservative. Gravitation force are conservative in nature. How we can prove it? That gravitational force is conservative in nature. Then here we can write there, let an object of mass m is raised through height h along different path against gravity. We are taking the different path, then we will find their gravitational force. If there is a force are equal along the different path, then we can say that gravitational force is a conservative nature. Now first we are taking this path, like this path, then object we are taking here, this one is the slant at the angle theta, then weight of this object will be exerted in downward direction, then reaction will be act in this direction, then this angle also will be theta, and this component we can say that mg cos theta, and this component we can write there mg sin theta. Clear? Now here case first we can write there along the inclined plane. This one is a type of inclined plane. Inclined plane. Now work done we can write there mg sin theta along this one CB. This one is the C and B. Here we can write, and this height we can write there h. Then we can write there this side, then CB cos 0. Clear? Then solid, then we can write there cos 0 will be our 1 and sin theta will be our into height into CB into CB. This to this cancel out here. Work done by this one by inclined plane we can write there MGH. Clear now? Next work done we will find on this staircase. Second work done along staircase. How we can find there? If we are taking this path like this path, then amount of work done will be there. How there is the height of this h, and there this height we are taking h dash, and here this distance is x. We are taking object is going on from this stairs, then we can write there let n number of stairs, here n number of the stairs, then we can write there n h dash is equal to h. Clear? Then work done we can write there n into mg h dash cos 0 plus along this height and along this horizontal and plus vertical. That's why we are taking this one mgx cos 90 degree. Clear? This component will be equal to 0. Now here left n mg h dash, and n h dash we can write here mg h. So work done along this different type of the path we can write there mg h. Now next, if we are taking third case, if we are taking the path like this, object is this one, then this is going in upward direction, their height is this one is h height and m is the mass. Then from here we can write their work done is equal to mgh cos 0, because their weight of this object is exactly downward direction mg and height acquired by this one mgh. Then we can write their mgh. From here we can write their different type of the path we are taking, but their work done is remain same. That's why we can say conservative force, gravitational force is a conservative nature. Now next our topic potential energy. Potential energy. Now potential energy we can say potential energy, or we can say elastic energy. Elastic energy of spring. Elastic energy of spring. The energy associated with state of compression or expansion of spring is called potential energy. Is called potential energy. Then we can write there V equal to half kx square. This is our potential energy, where k is spring constant, and x is a displacement of spring. X is a displacement of the spring. Now here we are taking this spring like this one spring. Here this spring is taking this here up to here. If we will stress it, this spring we will stress it, then we will take up to there. Then their displacement along this one will be our x displacement. As we will compress this one, then we can take this object here, then up to there. From here we are measure this one, then up to there, that is the compression between them, that we are taking x. We can say this one is the equilibrium position. Equilibrium position, that is a stretch position, and this one our compression position. Clear now? When the spring is compressed or stressed, then their restoring force is developed. When spring is compressed or stressed, then restoring force is developed. So by Hooke's law, this law will come in your next chapters. This, according to this law, that force is directly proportional to our displacement, and this is the opposite direction of the applied force. That's why we are taking negative sign, and this is k constant. As we remove this proportional sign, then always we will take a constant. So work done against these restoring force, small amount of work done by restoring force, then we can write there that dw equal to force into small displacement. Clear? And our force is acting restoring force, that's why this we can write there kx dx, small work done by the restoring force. Now total amount of work done we can write there, total amount of work done we can write there w equal to, taking integration on both side, then k we will take outside. Now here left dx up to 0 to x. Now after integration k remain constant, then we can write there x square by 2. Clear? This is total work done. Then applied force, then we can write there, then work done by applied force, then we will take it positive, is work done is equal to half kx square. Here we remove this one, then we can write there w equal to our applied force, we can write there, that is this one. That's why from here we can write there this. Now this work done is stored in form of the energy, so energy we can write there half kx square. Clear now? Up to this topic complete in your notebook, fair notebook. Next topic we will start in next class.